Someone get that child back to the visitors gallery. This is a symposium, not a daycare. Dr. Lawrence Whitfield waves his hand like he is shooing away a fly. He does not even look at the small black boy standing at the microphone. Did no one check credentials at the door? This forum is for serious researchers, not children playing mathematicians. A few people in the audience laugh. The boy's papers slip from his hands and scatter across the stage. I'm sorry, sir. I have a presentation scheduled. Number 47. His voice shakes. Quiet. Polite. The kind of voice that has learned to make itself smaller. Presentation? From Booker T. Washington Elementary? Whitfield squints at his tablet. Is this some kind of outreach program? More laughter now. The boy's face burns. What none of them know is that this terrified 10-year-old has just done something impossible, something no mathematician on Earth has managed in 30 years. His name is Elijah Brooks, 10 years old. Thick glasses that slide down his nose, a button-up shirt 2 sizes too big, borrowed from his cousin for today. Right now, he wants to disappear. The annual New England Youth Mathematics Symposium. Boston Convention Center. 3 days of presentations where the brightest young minds showcase their work. Except the bright young minds here all have a certain look, a certain background. Phillips Exeter Academy, Milton Academy, Boston Latin School. The kind of schools with Olympic-sized swimming pools and robotics labs that cost more than Elijah's entire school building. Elijah goes to Booker T. Washington Elementary in Roxbury. No advanced math program, no competition math team, just library books and YouTube videos and a notebook he bought with his own birthday money. Dr. Lawrence Whitfield sits at the judge's table like a king on a throne. 58 years old. Tenured professor at MIT, department head. His signature is worth millions in research grants. One word from him can launch a career or end it before it starts. He has decided Elijah does not belong here. And he is not the only one. Excuse me, son. Are you lost? That was the security guard at the entrance. 3 different times. Each time, Elijah showed his registration badge. Each time, the guard looked surprised, skeptical. In the bathroom, 2 boys from Phillips Exeter stood at the sinks in their tailored blazers. Did you see that kid in the waiting room? What's he even doing here? Probably some diversity thing. You know how they are now. They did not bother to lower their voices. Elijah stayed in the stall until they left. The symposium runs on an unspoken hierarchy. At the top, students from families where both parents have PhDs, where dinner conversation includes words like topology and eigenvalues, where summer means math camps at Stanford or MIT, not watching your little sister while your mom works double shifts. Elijah is presenting on the Hartwell conjecture, a problem that has haunted mathematicians since 1987. Dr. James Hartwell, a British mathematician, asked a simple question about coloring infinite graphs. Can you color any planar graph with 4 colors so that no 2 connected regions share the same color even when the graph extends infinitely? It sounds simple. It is not. For 38 years, hundreds of mathematicians have tried to solve it. Doctoral students have built entire dissertations around failed attempts. Tenured professors have published papers proposing solutions, only to have them torn apart by peer review. The Hartwell conjecture sits in that special category of problems that are easy to understand but impossible to solve. Dr. Whitfield himself has spent 3 decades chasing it. 7 published papers. Dozens of conference presentations, millions in research funding. He has not solved it either. Elijah does not know this yet, but 6 months ago, he found something. A pattern. A way of looking at the problem that no one else had tried. He spent his lunch periods in the library, filling page after page with colored pencil drawings of graphs. Testing. Checking. Following the logic wherever it led. He thought he found an interesting observation. Something worth sharing. He had no idea he had actually solved it. Back in Roxbury, 40 people crowd around a projection screen at the community math center. Kids from the neighborhood. Parents who took off work. Dr. Sarah Okonkwo, who runs the center and who convinced Elijah to submit his work to the symposium in the first place. She sits in the front row, hands clasped tight. On the screen, they watch Elijah standing frozen on that stage while Whitfield dismisses him like trash. A little girl, maybe 7 years old, tugs on Dr. Okonkwo's sleeve. Why is that man being mean to Elijah? Dr. Okonkwo does not have a good answer. Not one 7-year-old would understand. Not one that would not break something inside that little girl's hope. Sometimes people make mistakes about other people, she says quietly. But Elijah is about to show them how wrong they are. She hopes she is right. She hopes they give him the chance. Back on that stage, Elijah bends down to gather his scattered papers. His hands shake so badly he drops them twice. 800 people watch him scramble on his knees. Some look uncomfortable. Most look away. Dr. Whitfield checks his watch. Sighs like this is all a waste of his valuable time. What none of them understand yet is that the next 5 minutes will change everything. Elijah finally gathers his papers, stands. His legs feel like water. Young man. Whitfield's voice cuts through the murmurs. This forum is for original mathematical research. Do you understand what that means? Yes, sir. Elijah's voice is barely audible. I have observations on the Hartwell conjecture. The one about planar graph colorings. The room goes still. Several judges lean forward. The Hartwell conjecture is legendary in mathematics. Unsolved for nearly 4 decades. The kind of problem that makes careers or breaks them. Whitfield's smile does not reach his eyes. The Hartwell conjecture, I see. He exchanges glances with the judge beside him. Son, doctoral students have attempted that problem. Tenured professors at the world's best universities have failed at it. Are you telling me you've solved it? He makes air quotes around the word solved. A few people in the audience laugh. I don't know if I solved it, sir. I just found a pattern. Something maybe nobody saw before. The temperature in the room drops 10 degrees. A pattern I didn't see. Whitfield leans back in his chair. How interesting. He pauses, lets the silence stretch. Lets everyone absorb the absurdity of this claim. A child from an unknown school, claiming to see something that the greatest mathematical minds missed for 40 years. Tell you what, before we waste everyone's time, let's do a little warm-up. Simple problem. He stands, walks to the digital board behind the judge's table, writes with sharp, precise strokes. A sequence begins. 2, 6, 12, 20, 30. What's the formula for the nth term and why? It is a trap. Everyone in the room knows it. The problem is simple for any competition math student. N squared plus n. But Whitfield is not testing Elijah's math skills. He is testing whether Elijah belongs in this room at all. The audience waits. Some pull out phones. This is getting uncomfortable. A few people shift in their seats. In Roxbury, Dr. Okonkwo leans toward the screen. Come on, baby. Show them. Elijah stares at the board. His mind races. He knows the answer. That part is easy. But something else catches his attention. The nth term is n times n plus 1, he says quietly. It's the product of consecutive integers. Correct. Whitfield sounds almost disappointed. Now, if we could move on to... But that's not the interesting part, sir. Whitfield stops. Turns. Oh? The interesting part is that your sequence is wrong. You could hear a pin drop. Excuse me? Whitfield's voice has an edge now. You wrote 2, 6, 12, 20, 30 on the board. But look at the projection screen behind you. Every head turns. The screen mirrors the digital board, but something is off. Due to a glitch in the mirroring software, one number appears twice. The sequence on screen reads 2, 6, 12, 20, 20, 30. If your sequence actually has 20 twice, then the formula breaks down, which means either there's a transcription error or you meant a different problem. Elijah adjusts his glasses. His voice is still quiet, but steadier now. In mathematics, we're supposed to verify our assumptions first. That's what you taught in your 2018 paper on axiomatic systems. I read it. Silence. Complete, absolute silence. Then, from the back of the auditorium, someone laughs. Not at Elijah. At the situation. At the fact that a 10-year-old just corrected Dr. Lawrence Whitfield using Whitfield's own methodology. In Roxbury, the community center erupts. Kids jump out of their seats screaming. Dr. Okonkwo covers her mouth with both hands, tears already forming. On stage, Whitfield stares at the screen. His face has gone pale. He just got fact-checked by a child he tried to humiliate, and everyone saw it. Whitfield recovers quickly. You do not become a department head at MIT without learning how to handle embarrassment. Well, his smile is tight. Congratulations on your reading comprehension. Now, your actual presentation. You have 5 minutes. Elijah's hands shake as he connects his flash drive to the presentation system. What appears on screen makes several audience members blink in confusion. Hand-drawn graphs, colored pencils, uneven handwriting. It looks like a child's homework assignment, because it is. Dr. Whitfield, your conjecture asks if every planar graph can be colored with 4 colors. The rule is that no 2 regions sharing an edge can have the same color. And this has to work even when the graph extends infinitely. Elijah's voice is soft but clear. He has practiced this part 100 times in front of his bathroom mirror. Dr. Hartwell first asked this question in 1987. Since then, hundreds of mathematicians have tried to solve it. Nobody has succeeded. He clicks to the next slide, a simple animation showing finite graphs versus infinite ones. The 4-color theorem works for finite graphs. We know that for sure, but the infinite case is where everyone gets stuck. Whitfield leans forward slightly. Despite himself, he is curious. I think everyone got stuck because they were looking at it like a graph problem. But what if it's actually a tiling problem? Elijah clicks again. His slide shows a bathroom floor, tiles extending in a pattern. Simple. Visual. Something anyone can understand. If you think about coloring graphs, it feels impossible. But if you think about tiling a floor that goes on forever, you start to see patterns. When you tile infinitely, patterns repeat, like wallpaper. He clicks through several examples. Each one shows a different repeating pattern. Dr. Hartwell's question asks if coloring works for every possible infinite arrangement. But that's like asking what the biggest number is. There is no answer because the question itself has a problem. A judge in the back sits up straight. Dr. Patricia Ruiz